All right. Welcome to data mining, lecture number 13. So today we will continue with our discussion on neural networks that we introduced in the last lecture. Neural networks were introduced in the context of classification as well as regression. Uh, but today we will also see that neural networks can be used for representation learning, and those representations that you have learned can be used for other tasks as well. Including clustering and outlier analysis and other downstream tasks that you might want to apply on your data. So today, again, the lecture would be an overview of feed-forward neural networks, autoencoders. We might touch on RNN a little bit and then transformer. So we'll move at a slightly fast pace and we'll be using the notes. So neural network content is available in different books, but since we are doing it in a quick way, so we wouldn't be able to follow one particular book closely. So it's kind of following multiple books, you can say. I will give you the references from the textbooks for your reading purposes, but primarily you should be able to understand what we study in class. All right. So let's get started. Are there any questions? So we agreed in the last lecture that the quiz would be on Wednesday. So we'll have a quiz the coming lecture. And then next Wednesday is our midterm exam, which will be held in class in the same room as your classroom. All right. So in the last lecture, we had introduced one block of a neural network. And we said that that one block with certain output layer conditions is actually a logistic regression block. So in other words, if I want to write it schematically, you have some input. Okay? Input goes into the neural network block, and then you get the output. Okay? And in terms of equations, you have y is equal to some function, nonlinear activation function. W generally is a matrix multiplied with the input vector x plus a bias, which is also a scalar or a vector, depending on whether y is a vector or scalar. Okay, so this is the equation form, and the parameters for this one block of model is w and b. So these are the parameters that you would like to learn. Okay, so depending on what g is, if g is a logistic sigmoid function and y and b are scalar, then this is actually your logistic regression model where y can be considered as a probability distribution over the posterior probability of the class given the input x. Okay, so it can be used for classification. And of course, if g is a linear function, or in other words, there is no g, then you can use this equation for regression. It will primarily be a linear regression model, which you have studied in many other classes before as well. So you have uh, each parameter wi multiply with each input xi plus a bias which you can call w0 or b in this case. Okay? So, but neural networks kind of generalize this single block into multi-block block. And in particular, we are talking about the feed-forward neural network. Feed-forward neural networks have multiple such blocks. You can call them layers or blocks. So generally, if you have a k layer feed-forward neural network, it means that it has k blocks of the form that we uh, ठीक है, so of the form that we see above. So k blocks means that you have k such functions that are appearing before you get the final output. So to understand this, you need to have some way of quantifying the notations or specifying the notations. So again, lot of variety is used, but we'll try to stick with a simple notation. So generally we use X to denote the input and Y to denote the output of the entire network. ठीक है? And A is the output activation of any particular layer. So you can use output of a particular layer or block can be represented by the vector A. And as we saw in the last lecture also, we use Z to denote the, uh, you can, before applying activation output of a layer. So in other words, जैसे हमने पहले भी पर जो लिखा हुआ है, तो Z जो है ये आपका आउटपुट है A. ठीक है, और Z इज WX+B. Z बेसिकली जो आपकी पिछले लेयर की जो कंबाइंड इनपुट आ रही है वो Z है, and after applying the activation you get the output A. And if this is the last layer, then of course as you know हम इस A को Y भी कह सकते हैं. ठीक है. So now again, instead of using A, yeah, I think to make the notation even more consistent, we can use the notation that the first the input to the first layer is x0. इसको of course I have written 0 in front of it. You can write it in different ways. Different लोगों ने use किए हुए. You can say it's a superscript bracket 0. ठीक है, but I'll for simplicity आगे मैं 0 लिख दूंगा. You will understand what this means. So what is this input to first layer? ठीक है. So similarly x1 would be input to second layer and so on. And this input to the second layer is actually the output of the first layer. Okay? So if you use this notation, then we can have a very consistent formula for our feed-forward neural network. So do you understand this notation? So x0 the overall input to the neural network hai, which we called x before, and x1 is the input, of course, again using the same analogy to the second layer. But this x1 is the output of the first layer. So it's both things. Output हमने ऊपर A कहा था, ठीक है, output A है. And of course, if you have a K neural network जो xk होगा, this would be actually be Y. So for example, so xk so xk क्या होगा? So this is output of input to the K layer, and this also is the output of the xk होगा. एक सेकेंड, हाँ ठीक है, k+1 होगा ना. ठीक है. So X1 is the first layer. So एक second. ठीक है, आउटपुट ऑफ द फर्स्ट लेयर, ठीक है सही है। ठीक है, so this is the output of the kth layer, ठीक है, and of course this is the output. We don't have any other input to the next layer. This is the last layer. So of course xk is equal to y in our previous case, ठीक है। So you can think of these blocks as added in series one after the other. So overall, for any particular uh, layer, you can write an equation like this: x. I put this in brackets here so that confuse now, I plus 1. So g w. Now we also need uh, parameters that are different for each layer, ठीक है। So the output, so basically जो आपकी output आ रही है I plus 1 पे, this is actually represented I plus 1 layer, ठीक है। So we'll use this I plus 1 इधर आ गया। हमारे पास जो इनपुट है ये ith की है प्लस b I plus 1. So for I is equal to 1 to k. So this single equation can represent the entire feed-forward neural network, ठीक है। ठीक है। So this single equation, of course, there will be multiple such equations depending on the number of layers, would represent the complete feed-forward neural network from input to output, ठीक है। So we are talking about k layer neural network. जो final output होगी वो x I plus 1 होगी, k plus 1 होगी, which will be your y. And of course the first x जो आपके पास होगा, x let's say 1 से हमने शुरू किया हुआ, या 0 से कर लेना चाहिए था हमको, I think 0 से कर लें, ठीक है। तो 0 to k, so this would now be your complete neural network. So this is, in other words, called a k layer feed forward neural network. So it has k blocks, so k blocks of processing. 0 to k minus 1, that's what you're saying. uh, because I plus 1, हाँ ठीक है, उसका लेयर वो बन रही है एक एंड वाली, ठीक है। तो स्क्रिप्टिंग, ठीक है। सो वी हैव k layers and the last index would be k minus 1, because जो अंदर जो हमारे पास पैरामीटर बन रहा है w I plus 1, and so k plus 1, that's the kth parameter. So we have k set of parameters. जो जितने पैरामीटर्स उतने लेयर्स होते हैं हमारे पास, उतने ब्लॉक्स हैं, तो ठीक है। सो यू आर राइट, सो इंडेक्स जो है वो k minus 1 तक जाएगा, ठीक है। So now, obviously, given these equations, you can process any input x through the neural network to get the output y, given the number of layers. And of course, given the parameters w and b, w for each layer and b for each layer. जी हमने लास्ट टाइम बात की थी, जी फॉर ए न्यूरल नेटवर्क for the internal layers it is always going to be a nonlinear activation function. So for it's going to be a nonlinear activation function. Otherwise, we don't get any benefit if you use a linear activation function. So it's going to be nonlinear. And commonly we use, for example, the tangent hyperbolic function, or the rectified linear unit. Okay. So tangent hyperbolic function goes between 1 and -1, and it's of course continuously differentiable. The rectified linear unit is also nonlinear, but it has two straight line components. So for example RL LU जो function होगा for any z, ठीक है. So this is basically max of z and 0, ठीक है. So in other words जो output आपका आएगा given a score that is generated at a layer z, of course z यहाँ स्केलर वेक्टर होगा तो एलिमेंट वाइज अप्लाई होगा, ठीक है. Element wise apply होगा. तो if z is positive then you output z, if z is negative you simply output 0. So it's kind of a function like this. 0 पे एक kink आता है and then goes linearly above, ठीक है. So the primary reason for using this is computational efficiency. uh, uh, so you can obviously use the tangent hyperbolic as well, and also it has a slight regularization uh, uh, factor as well. That's another reason, because इसका जो negative part है वो हम clip off कर रहे हैं, ठीक है. So in a way you are kind of more or less randomly clipping off some nodes, some units in different batches of your processing, ठीक है. So इससे आपको एक regularization impact मिलता है, which is good for improving the performance, generalization performance of your neural network. So that's why this is more common nowadays. Although tangent hyperbolic theoretical perspective से ज़्यादा beneficial है, but practically ReLU works well. Okay, so this was the internal layer. What about the output layer? So G for output layer. So this is dependent on your actual task, and we talked about this last time. So if it is a binary classification, so we use a logistic sigmoid. If it is multi-class classification, we use the softmax. If it is regression, we simply use the linear function, ठीक है. Okay, so we have completely specified the neural network, the feed-forward neural network, input, output, layers, activation functions, and parameters. Of course, the learning problem, which we won't go into detail, is to find all the parameters. So find all W's and B's, ठीक है. This is the learning problem, and we do it given training data. और training data में आपके पास input output pairs होने चाहिए x and y, and then we find these by solving an optimization problem. So you need to have an objective function or loss function, as we say in machine learning. Loss function is also task dependent. हमने ऊपर तीन task define किए थे: binary classification, multi-class classification, regression. So हर task के लिए loss function different होगा, ठीक है. So for binary classification, so binary क्लासिफिकेशन के लिए क्रॉस एंट्रोपी यूज होता है, मल्टी क्लास के लिए भी क्रॉस एंट्रोपी होता है, बट वी कॉल इट मल्टी क्लास क्रॉस एंट्रोपी, उसकी एक्सटेंशन है. So this is called the multi-class cross entropy. And then for regression, usually we use the sum of squared errors. Okay? So these are the loss functions that are commonly used. So objective function, जो loss function होता है आपके पास, which is a function of W and B. ठीक है? So let's say it's SSE. Sometimes for regularization purposes, we'll also add another function, let's say K of W and B. ठीक है? So you might have studied this elsewhere as well. तो ये जो K function है, this is called the regularizer. ठीक है? And regularizer का मकसद ये है कि we don't want to overfit our model to the data by ensuring that the parameters, all the parameters W's and B's do not become very large. So हम ये add कर देते हैं उस loss function में, और we tend to minimize the entire loss L. Since उसमें ये add किया हुआ है, इसका मतलब वो parameters को भी छोटा करने की कोशिश करता है, ऑब्जेक्टिव फंक्शन छोटा करने की कोशिश करता है थ्रू द ऑप्टिमाइजेशन प्रॉब्लम. सो लॉस फंक्शन रेगुलराइजर, ऑफ कोर्स L1 रेगुलराइजर होता है, L2 होता है. आई वोंट गो इनटू द डिटेल्स, बट just for your refresher, uh, so that's one way of ensuring that you do not get overfitting. Plus there are some other tweaks, you can say, for preventing overfitting. So we are talking about overfitting, for example. So one is of course regularization, loss function regularization. And then there are other techniques that are based on training, for example, early early stopping, for example. So you do not run the optimization for a long time, you stop early. So in other words, overfitting to the data is prevented. And of course, to do this, you need to have a validation set. So again, these things you should know from your previous classes. Of course, a few years back जब ये AI ML एक कोर नहीं होता था, मैंडेटरी नहीं था या सारे लोग नहीं लेते थे, we did cover this in slightly more detail. But here it's more of a refresher. ठीक है? But of course, if you have any questions, you can ask. In other words, loss, this is the regularizer term. So early stopping हो गया. And also more recently and quite popularly, we can use the dropout approach, in which random we select layers, we select units, meaning that individual outputs हम zero कर देते हैं. Of course, we do this in a randomly fashion in different iterations of your training process. So this forces the model to generalize, not to kind of use one unit to learn one particular pattern always. जब वो एक pattern fix use learn कर लेता है, तो then that is overfitting. We want it to generalize. So dropout use होता है, and then of course layer normalizations काफी commonly use होती हैं. Layer normalizations का जो regularizer impact है कम है, but it's still a beneficial thing to do. ठीक है? And there are some other techniques as well. I wouldn't go into the other details. छोटी मोटी और techniques भी हैं. But since you are going to implement some of these in your assignment too, so I wanted to give a quick refresher here. Okay. Any questions so far? Okay. Uh, of course, the optimization techniques may be various variations हैं, but all of those variations are part of the stochastic gradient descent optimization technique. So SGD, stochastic gradient this is an iterative optimization technique that uses the first derivative. Remember, ऑप्टिमाइजेशन में आपको लॉस फंक्शन का डेरिवेटिव निकालना पड़ता है, ठीक है? तो फर्स्ट डेरिवेटिव जब ज़ीरो होगा ऑब्वियसली दैट मीन्स दैट दैट रिप्रेजेंट्स ए लोकल मैक्स और इन दिस केस बेसिकली लोकल मिनिमा ऑफ योर मॉडल, ठीक है? तो so that's the point that we are trying to find in stochastic gradient descent approach in an iterative fashion. For multi-layer feed-forward neural network, the optimization problem is in general non-convex, meaning that you would you are you're not guaranteed a global optima. लोकल ऑप्टिमा आपको शायद मिल जाएगा बट ग्लोबल ऑप्टिमा गारंटीड नहीं है. सिंगल लेयर के लिए फॉर लॉजिस्टिक रिग्रेशन इट इज गारंटीड, फॉर मल्टी लेयर इट इज नॉट. ठीक है. अब इसकी वेरियस वेरिएशंस हैं, यू माइट नो एडम यूज होता है, मोमेंटम है एंड देयर अदर थिंग्स एज वेल. सो we don't want to go into those details here, but you should know about them because you might see them in the implementation. ठीक है. So any questions before we move on to the next architecture? So पैरामीटर्स आपके पास वो W's हैं और B's हैं. These are the things that you learn from data. But oftentimes there are many other things that you can change and tweak and see whether your performance improves or not. So those are usually called hyperparameters. So hyperparameter में बहुत कुछ आ सकता है. So इसमें for example number of layers, this is a hyperparameter. Number of units per layer, this is a hyperparameter. Activation function to use, this is a hyperparameter. Stochastic gradient descent के जो पैरामीटर्स हैं उसके पैरामीटर्स हैं, मोमेंटम के पैरामीटर्स हो सकते हैं, अदर पैरामीटर्स जो स्टेप लेंथ के पैरामीटर्स हो सकते हैं. ये all of these would be part of hyperparameters. So lots of hyperparameters actually. So you can classify them as architectural parameters. Architectural parameters, number of layers हो गए, number of units per layers हो गए, and so on. And optimization parameters, जो SGD parameters हैं, regularization parameters भी होते हैं. So dropout के parameters हैं, regularization के, and etc. So there are lots of hyperparameters. So to find the best model, you will probably be tweaking with many parameters and before you get the results. So once you have selected the best results, then you can use the model for prediction. And that is from a data mining perspective, the learning process, the discovery process. ये सारी चीजें आपने फिक्स कर ली हैं तो आपने एक मॉडल लर्न कर लिया, डिस्कवर कर लिया और वो फिर आप बाद में यूज कर सकते हैं. एंड एसेंशियली वो आपके पास वही मॉडल जो मैंने ऊपर इक्वेशन लिखी थी, xi+1 is equal to gw i+1 xi plus bi. ठीक है. सो ये आपने फिर अप्लाई करना है स्टार्टिंग फ्रॉम द इनपुट, go to the next layer, go to the next layer until you get the final output. So that is the output that you desire. It might be a regression output, continuous output होगी, it might be for a probability for classification. ठीक है. अच्छा, one other thing, the number of units मैंने ऊपर लिखा था per layer. So for example, the first layer होगा उसका आप n1 कह सकते हैं, n2 कह सकते हैं, and last layer के nk. ठीक है. So these are the number of layers. You have to fix these. So generally आपके पास जो of course n0 भी आप कह सकते हैं. Input कितना है? Input would be equal to the size of the vector x0. N1 would be the size of the vector x1, or sorry, a1 you can say also. ठीक है. Similarly and so on. So generally आपका जो भी input है x, let's say n0 मेरे पास let's say 100 है. ठीक है. So this is your input dimension. आगे हम input dimension को हम generally okay, generally we reduce this we embed this input into smaller dimensions until we get to the output. So in other words, n1 would generally be less than n0, and similarly nk would generally be less than nk k minus 1. चलिए, किसी का क्वेश्चन था? आई थिंक आई सॉ ए नोटिफिकेशन. किसी का क्वेश्चन है? ऑलराइट. सो एग्जांपल फॉर एग्जांपल हो सकती 100 है, 50 है, 10 है. लेट्स से a binary classification problem, final layer would have just two layers. So binary classification. तो जो आपका आउटपुट लेयर है, इट विल जस्ट हैव 2 यूनिट्स. इनपुट आपका 100 है. ठीक है. 50, 10. So this would actually be a 3-layer neural network. Remember, input हम काउंट नहीं कर रहे होते. Remember, the first block होता है वो 50 वाला ब्लॉक है, उसका इनपुट 100 है. The first block 50 है, second 10 है, third 2 है. So there are 3 blocks, 3 layers. So this is a 3-layer neural network. So input is usually embedded into spaces that are of smaller sizes until we reach the desired space which gives us our answer. ठीक है. हमारा फाइनल स्पेस जो हमने कैपिटल वाई लास्ट लेक्चर में रिप्रेजेंट किया था, कैपिटल वाई इज आउटपुट स्पेस, उसकी जो डायमेंशन होगी जनरली वो छोटी होगी. So the final layer would represent just dimensions of your output space. So the question is, why do you need multiple layers? So you might have studied this in AI ML as well. So multiple layers is required to help the model find a better representation for the output space in an iterative or step-by-step process. ठीक है. Remember, हमने final हमको y space में results चाहिए. So we could go directly from input to y. ठीक है. But that may not be possible, especially if that input to output y is a linear transformation, because linear transformation has very little capacity. While in a feed-forward neural network, we do two things. We go through multiple layers, and each of those multiple layers or multiple spaces is a nonlinear transformation. And you give the model greater capacity to find such spaces intermediately so that we get a final space that can solve the problem in a better way. ठीक है. So इसमें non-linearity बहुत important है. If all of these layers were linear, then there is no benefit in having multiple layers. So we need that non-linearity, and then we need the multiple layers so that the model is able to find that in a more convenient way rather than in one step. So theoretically, a 2-layer feed-forward neural network is equivalent to any higher order neural network. But as I said, practically higher layers does give us benefit in practice. So in theory, so might have studied this before as well. A sorry, a two-layer feed-forward neural network is a universal approximator. Of course, ये two-layer with non-linear activation function. But in practice, we tend to increase the number of layers. By the way, one layer होगा तो वो logistic regression है. ठीक है? Two layer and more layers becomes feed-forward neural network. Two-layer theoretically is a universal approximator, meaning that it can learn any input-output mapping as long as we have enough data. थ्योरी ये कहती है, बट प्रैक्टिस में हमने देखा है कि दो से ज़्यादा कर लें कई दफ़ा हमको बेहतर इनपुट आउटपुट मैपिंग मिल जाती है. ठीक है, सो
So
दैट्स
basically,
आंसर टू योर
so
क्वेश्चन.
basically non-linearity है.
एनी अदर क्वेश्चन? अच्छा ठीक है. सो व्हाट एग्जैक्टली इज द that you don't understand? Can you explain it a bit more?
नहीं मैं कह रहा हूँ नो क्वेश्चंस.
मैंने समझ नहीं आई, फिर से बोले.
मैं कह रहा हूँ कि आई हैव नो क्वेश्चंस, समझ आ गई.
अच्छा नो क्वेश्चन, अच्छा सही है, ठीक है. ठीक है. So universal approximator, of course, from mathematical theory, any any function, any model is universal approximator. It can, if whether when if it can learn a mapping from input to output with any arbitrary degree of accuracy. Of course, this would depend on the data. Data भी unlimited होना चाहिए. ठीक है. But as I said, in practice, more than two sometimes help. So in other words, feed forward neural networks, minimum number of layers is two. One layer लेंगे तो वो आपका logistic regression है. Logistic regression is a good model and it would work in many cases, but for more complex problems, we need a feed-forward neural network. It should have as a minimum two layers and it can have more than two layers. ठीक है. So any other question? One quick point here before we move on to the next model. Time जो है ना fly करता है. Anyway, so one अब जो intermediate layers हैं, जैसे मैंने ऊपर example दी थी, we started with 100, with 50 and 10 before the output. So for any given input X, you can get the output from the 50 layer or you can get the output for the 10 layer. So those would be representations of the input at various stages of the model, or or you can call them as embeddings of the input in the 50 dimension space and in the 10 dimension space. And this is sometimes also called learning representation. So of course we are solving a task like classification या regression, but वो हमारा ultimate goal नहीं है. हमारा ultimate goal था कि हमने जब ये मॉडल लर्न कर लिया, जब हम नया x देंगे उसको, हम क्लासिफिकेशन के लिए नहीं दे रहे, हम जो 10 यूनिट्स की लेयर की जो आउटपुट है वो लेके हम उसकी एक रिप्रेजेंटेशन ले ली और वो हम आगे का आके कहीं यूज कर रहे हैं. ठीक है. So this is called representation learning in general and it has various shades as we will see when we discuss autoencoders, transformers and so on. ठीक है. ठीक है. Okay, so now let's just go on to the next model, which is the autoencoder. ठीक है? So autoencoder is also a feed forward neural network. So जो हमने पूरा ऊपर feed forward neural network डिजाइन किया था input to output, it can have 2 or more layers. So autoencoder भी वही है, बट इसमें एक चीज डिफरेंट है, इसमें जो टास्क है is different. So task is to predict the input uh, इसको so in other words to reconstruct the input. So the task is to reconstruct the input. ठीक है? So let me explain. So let's say हमने कहा था हमारा input 100 dimensions था. ठीक है? So x0 is 100, let's say. ठीक है? So our task is to input x inputs through the neural network, and at the end of the neural network we also want to regenerate this 100 dimension input. Okay, so essentially an autoencoder therefore consists of two uh, you can divide it into two feed forward neural, although it's technically is one feed forward neural network, but थोड़ी सी शेप डिफरेंट होती है. पहला एक फीड फॉरवर्ड नेटवर्क है जिसमें डायमेंशंस कम हो रही हैं, और दूसरा फीड फॉरवर्ड नेटवर्क में डायमेंशंस बढ़ रही हैं. So the first one we call the encoder, and the second we call the decoder. So let me give an example here. Let's say input मेरे पास 100 था, तो 50 पे गया मैं, 50 पे गया, 10 पे गया, and then I go back to 50 and then go back to 100. So this is my entire feed forward neural network. The first part, 100, 50 to 10 is the encoder, and then 10, 50 and 100 is the decoder. But together it's one pipeline, one block. In other words, जो ऊपर मैंने पूरा नेटवर्क लिखा है 50, 10, 50 एंड 100, कितने लेयर्स होंगे? 50 एक है, 10 दो है, फिर 50 तीन है, और 100 चार है. सो दैट्स ए 4 लेयर फीड फॉरवर्ड न्यूरल नेटवर्क. ठीक है? एंड जो दिस इज जनरली सिमेट्रिक. जो आपका इंकोडर होगा, डिकोडर भी उसी तरह का रिवर्स चलता है. ऑल्दो थोरेटिकली इज नॉट गारंटीड, पर प्रैक्टिक थोरेटिकली इज नॉट नेसेसरी, पर प्रैक्टिकली हमेशा ऑलमोस्ट ऑलवेज इस तरह ही रखते हैं हम, कि एनकोडर में हम एम्बेडिंग की साइज छोटा करते जाते हैं, जो मिनिमम एम्बेडिंग आती है उसके बाद से फिर हम डिकोडर से उसको फिर बड़ा करके ओरिजिनल डायमेंशन स्पेस पे चले जाते हैं. ठीक है? सो ऑल ऑफ दीज layers are your standard feed forward blocks. ठीक है? और जो सारी ऊपर हमने कहानी पढ़ी थी, क्वेश्चन देखी थी, वो वही रहेगी. इंटरमीडिएट लेयर्स की जो आपके पास एक्टिवेशन फंक्शन, दे हैव टू बी नॉन लीनियर. If they are linear, then there is not much benefit in using a uh, autoencoder. Of course linear लेंगे तो ये PCA को approximate करेगा, principal component analysis or other linear transformation like SVD. But since we are dealing with more complex data, we will prefer non-linearity, and we will use non-linear activation functions, usually tangent hyperbolic or uh, rectified linear units. ठीक है? But what about the output layer? We said that it's so in other words हमारे पास x नॉट था, ऊपर हमारे पास 4 लेयर थी. ठीक है? So we'll have, so this is my input, so x4, this is my output. ठीक है? इसको मैं x कह देता हूँ, इसको मैं y कह देता हूँ. ठीक है? but this y is actually reconstruction of my input. पहले मैंने इनपुट x को एक लो डायमेंशन स्पेस में एम्बेड कर दिया 10 डायमेंशन लेट से. सिंस ऑफ कोर्स जब आपने एक हाई डायमेंशन लो डायमेंशन में, देयर माइट बी सम लॉस ऑफ इंफॉर्मेशन, राइट. एंड देन उस छोटे डायमेंशन से वापस मैं जनरेट कर रहा हूँ फुल स्पेस. सो रिकंस्ट्रक्शन में बी एरोनियस. सो हमारा जो लॉस फंक्शन इसमें बेसिकली यही पे चेक करता है कि जो हमारे पास रीजनरेटेड वेक्टर है, हाउ क्लोज इज दैट टू द ओरिजिनल वेक्टर. ठीक है. सो एसेंशली आपके पास जो लॉस फंक्शन होगा इसका एट द एंड लेयर L is basically so you can actually write it as sum of squared errors as well of y and x. But y वही output है uh, that you get, and x of course is the input, and both of them should uh, we are trying to force the input to get the true output y. ठीक है. So इन दोनों में जो difference है वो हम कम करने की कोशिश करेंगे. So in this context जो output layer की जो आपकी है activation function है, it's usually linear because हमारे पास एक regression output आ रही है. ठीक है. बट इन सम केसेस इफ यू आर, हमारे इनपुट सारे बाइनरी हैं, 0 1 है 0 1 है, तो ये आउटपुट लेयर में आप लॉजिस्टिक सिग्मॉइड भी यूज कर सकते हैं. बट यूजली हमारे पास इनपुट्स 0 1 नहीं होते अनलेस यू नॉर्मलाइज देम. इनपुट्स हमारे पास वुड नॉट ऑलवेज बी बाइनरी. ठीक है. इन दैट केस आउटपुट लेयर की जो एक्टिवेशन फंक्शन है वो लीनियर होगी. So as you can see in this case, this is actually self supervision. So आपके पास कोई एक्सटर्नल लेबल कोई नहीं है. So your data actually is essentially your x. ठीक है. I is equal to 1 to whatever the number of size of data. ठीक है. So remember when you did classification regression, आपके पास y भी था, which was the label or which was the output. In this case जो ही आपका x है वही आप आउटपुट ले रहे हैं. This is called self supervision in machine learning. और ये कॉन्सेप्ट हैज बिकम वेरी पॉपुलर फॉर रिप्रेजेंटेशन लर्निंग. और यहाँ भी बाय द वे जो हम काम कर रहे हैं वो रिप्रेजेंटेशन लर्निंग ही कर रहे हैं. सो वंस यू हैव लर्न दिस मॉडल बाय अप्लाइंग दिस लॉस फंक्शन ऑन ए डेटा दैट हैज जस्ट x इन इट, you can now generate representations for this x. Input this x into your feed forward neural network. जो intermediate layers की output हैं वो इसकी representations बन जाएंगी. You can get an output for 50 dimension space, output from 10 dimension space, and so on, depending on the neural network that you have used. ओरिजिनल आपके पास 100 थी, आपके पास 50 की रिप्रेजेंटेशन भी आ गई है, 10 की भी आ गई है. ठीक है. So we will talk about the representation in more detail later on as well, but one very quick, क्यों हम representation हमको चाहिए क्यों? So one quick answer is that you can use it for clustering. ठीक है. So clustering में आप k means for example use कर सकते हैं on a representation that is of size 50 or 10. ठीक है. Instead of using the original dimensions of 100. और उसमें एक और इशू भी है. The original dimension may contain categorical as well as numeric attributes. The embeddings will always be numeric, and they will always be dense unless you have added a sparsity constraint. So that's another matter. Sparsity constraint भी कई दफा हम डालते हैं, but in most cases we don't. ठीक है. So it will be dense in the sense that सारी values non-zero होंगी. It might be positive, it might be negative, especially if you're using tangent hyperbolic. The tangent hyperbolic, as I said, he recommended for autoencoder, not rectified linear unit. ठीक है. So you typically use tangent hyperbolics in autoencoders. और यहाँ मैं वेक्टर्स कह रहा हूँ तो डिपेंडिंग ऑन द शेप ऑफ योर इनपुट ये यू कैन बी डिफरेंट एज वेल. फॉर एग्जांपल ऑटो एनकोडर इमेजेस पे भी अप्लाई कर सकते हैं, टेंसर्स पे भी कर सकते हैं. तो दो ऑफ कोर्स यू कैन linearize them and call them vectors as well. ठीक है. All right. Any questions? Okay, so let's talk. Okay, so the autoencoder, as I said, tries to learn the input. Okay, and the eventual goal is mostly learning representation. Okay, since we are not using any external signal Y, and but in a way we want representations that are smaller and denser that we can then use in later tasks like clustering, as I said. ठीक है. तो अब मेरे ख्याल से what you don't probably understand is the loss function. So हमारे पास let's say input x है. ठीक है. This is an input x. This input x, if you pass it through the neural network, it will generate an output y, which would be a representation of x. ठीक है. So let me call that x. X is input. So x prime मैं कह देता हूँ output of auto encoder, and this is or reconstruction. ठीक है. So हमारे पास जो लॉस फंक्शन है वो essentially in vector form is this x minus x prime. So let's say vector ये मेरे पास columns थे, तो इसका मैं ट्रांसपोज लूंगा. ठीक है. And then x minus x prime. So you're trying to minimize the difference. This is by the way the L2 norm. ठीक है. Or it's also equivalent to the sum of squared error, but vector notation में मैंने लिखा हुआ है. We are trying to minimize the difference between x, that is the actual input, and the input that is regenerated by the decoder as x prime. ठीक है. So once you minimize this, you will be fixing your neural network. Meaning fixing a neural network, वो सारे parameter w's और b आपको मिल जाएंगे. जब w's और b मिल जाएंगे, then you can give any new x to the network and get outputs not at the last layer of x prime, but at any intermediate layer and use that as representations. By the way, at the last layer x prime पे भी use कर सकते हैं. We can use that for outlier detection. Uh, I wanted to talk about that maybe later on, but यहाँ भी हम discuss कर सकते हैं. So outlier detection की technique भी एक is based on the autoencoder. So this is basically your loss function. So after minimizing this, your w's and b's are fixed. Now you can use the network to get representations for any new x. कोई भी नया x देंगे, आपके पास इंटरमीडिएट लेयर्स की जो आउटपुट्स आ रही हैं, द एज आ रही हैं या जो x आ रहे हैं उसके, वो आप यूज कर सकते हैं फॉर योर रिप्रेजेंटेशन. And those representations, as I said, would be usually dense and they will be continuous. So very quickly, we are running out of time. Remember, let's say think of any tabular data. मतलब tabular data में let's say age है मेरे पास, occupation है मेरे पास, salary है, सैलरी है, लेट्स से जेंडर है, एंड मैनी अदर एट्रीब्यूट्स हैं। ठीक है, ये हमारे पास इनपुट डायमेंशंस एंड ईच ऑफ दीज वुड बी, some of them might be categorical, some of them might be numeric. So you will have to transform them into a form that can be used by neural networks. Okay. So for example, occupation is categorical, discrete. Okay. So you will have to convert this into a one hot encoding. So let's say आपके पास three occupations हैं. So student है, teacher है और staff है. ठीक है ना? So you will have to convert this into a 0-1 encoding. So we'll have three outputs. So आपके पास 1, 0 और 0. This would mean that this is a student, and then 0, 1 and 0. This would mean that this is a teacher, and then 0, 0 and 1. This would mean a staff. तो अब ये न्यूरल नेटवर्क के अंदर जा सकता है. So you will convert this data into numbers. I would not call them numeric attribute, but numbers, so that it can be fed into neural network. And all categorical data would be converted into numbers using usually one hot encoding. और जो आपके पहले ही numbers हैं, if you want, you can scale them a little bit. Let's say age है और salary है, both of them are different. उसके min max हैं, so you might want to reduce them to some standard min max and then feed into the neural network. So this would be the input. जब आप एक ट्रेंड ऑटो एनकोडर के अंदर घुसाएंगे तो आप इसकी एक रिप्रेजेंटेशन ले सकते हैं एट एनी लेयर. लेट्स से यू कैन गेट रिप्रेजेंटेशन एट 10 डायमेंशंस. अब वो जो 10 डायमेंशंस वाली जो रिप्रेजेंटेशन होगी, इट विल ऑल बी नंबर्स. वो नंबर्स होंगे 0.25 होगा, कोई लेट्स से -0.1 होगा, लेट्स से 0.5 होगा, तो लेट्स से 1.1 होगा, एंड सो ऑन. So this would be usually a dense representation at an intermediate layer. And this representation can then be used, as I said, for downstream tasks that can include classification, that can include prediction, that can include outlier detection, that can include summarization, as well as जो हमने कहा था clustering. ठीक है. So we have run out of time. So are there any questions? So next class में quickly again, I'm sorry थोड़ा सा हम quick पढ़ रहे हैं, but ये because not the main focus, but I hope कि ये refresher and a different perspective would try to solidify your understanding of neural networks. But next lecture में जैसे मैंने कहा, so we'll talk about recurrent neural networks briefly and then transformers. And then again, of course, we do have a quiz at the end of next class.
सर मेरा एक क्वेश्चन है.
जी जी.
Sir, like, as a data person who is doing data mining, a data scientist, like, why would I care about these more in depth of this AI and ML? So why won't I just use a software to run it?
Why just use the software?
हाँ, तो जिस तरह हम जैसे रिग्रेशन रन करता हूँ, तो उसमें बजाय कि मैं इतनी डिटेल्स में इसके जाऊँ मैं, so why would I need to know this in that much detail?
Actually, there's a difference between a simple, you can say, business analyst and a computer scientist or a machine learning engineer. So business analyst might not care about these things. But if you want to be a machine learning engineer or a data scientist, then you do need to know these things. So उसमें because these things do play a significant role in the final result that you get. If you're not able to understand some of these things, then you may not be able to track any issue in the output that you are getting. So you might press a button, get a result, then you say, we might think the results are fine, but they may not be fine. तो उसमें issues overfitting के आ सकते हैं, उसमें issues, for example, जैसे मैं अब whole discussion कर रहा हूँ auto encoders की, why should one use an auto encoder? Why not just use the input dimension और solve the problem? उससे भी कर सकते हैं आप solve. Input dimension से कर सकते हैं, आंसर आ भी जाएगा, but it may not be the best answer because the representation that you have is not ideal for the task. So you'll have to try out an autoencoder, get a representation that is in a lower space, and then run it again. तो ये सारी चीज़ें इसलिए हम पढ़ते हैं. If you just want to be a business analyst who just have a software and data button दबाए आंसर ले, you might get the result, but it may not be the optimal result.
ठीक है, मेक सेंस, मेक सेंस.
ठीक है. Anything else?